Let's start with some common knowledge. Back in Unit 2, we were making equations of lines by looking at a picture of the graph. So for instance, in this example right here, we can write the equation of this line, y equals mx plus b. That's the generic form. That's our slope-intercept form, if you recall. All we need is the actual value for the b and the value for the m, and we would have a specific equation for this line. So it's real simple to see that right here is our b value, our b equals 5. We can also count up 5 blocks over 2 blocks, so we know that the slope is 5 over 2. So then we simply replace the m and the b, and we have our equation. We can do that for a number of lines. The trouble comes in Unit 3, now we don't have lines, now we have parabolas. These are also different shapes that we're going to encounter as we go through all of Algebra 2. We've finished looking at lines, now we're looking at parabolas. So how do we do that same thing for a parabola? Well, just like the line, we can start with the generic form, y equals ax squared plus bx plus c. This is the standard form for a parabola or a quadratic. What we're going to do is rewrite this ax squared plus bx plus c, and we're going to put the y on the other side. In a moment, you'll see why that makes a little bit more sense. That's what we're going to start with. Now, in the last problem, we just needed the value for m and the value for b, plugged them right in, and we had our equation. Well, we don't know what the value of a or b or c is in this example. Consequently, we need another strategy, and here it is. We're going to pick 3 nice points that are on this graph. So I'm choosing the point 0, 0. I'm choosing the point 2, 2. And the point 3, 6. These are all nice points. They have integer coordinates. What we're going to do next, we're going to take this equation, and I'm going to actually copy it and paste it 2 more times. I'm going to paste it here. All right, I've written it 3 different times. Next, I'm going to remove the x from each equation and replace it with parentheses so that I remember where it was. I'm also going to remove the y's. Now I'm going to take each one of these points, 3, 6, 2, 2, and 0, 0. And I'm going to write a new equation. I'm going to put the 3 wherever there was an x. And I'm going to put a 6 where there was a y. Here I'm going to put a 2 in place of x. And I'm going to put a 2 in place of y. And finally, 0 for x, 0 for y. The next thing we're going to do is simplify these. We don't typically say a3 squared. Instead, we just say 9a. We don't say b3, we say 3b, because 3 times b is 3b. And then finally, plus c equals 6. Next, a2 squared would be 4 times a, plus 2b plus c equals 2. And finally, 0 squared times a is 0, 0 times b, c equals 0. What we now have here is a good old-fashioned step 9 problem, where we just need to use our matrix to finish solving. So we would have 9, 3, 1, 6, 4, 2, 1, 2, 0, 0, 1, 0. When we put this in the matrix and reduce it into Desmos matrix, we will be left with our row reduced echelon form matrix here. Go ahead and put that into Desmos. I'll just share my screen with the other half that I need. All right. So this is my matrix. It's going to be 9, 3, 1, 6, 4, 2, 1, 2, 0, 0, 1, 0. You can see the answer ends up being 1, negative 1, and 0. So what does that mean? That means that A equals 1. That's my A value. B equals negative 1, and C equals 0. So when I take these values here and go back to where I started in standard form, my equation is y equals 1x squared minus 1x plus 0. That equation would generate that graph. Now that you have this example, you can go back and try other examples on worksheet C from Unit 3. Step 10, worksheet C, there's a few examples where you just have to find 3 points on the parabola, and then you can generate this 3-system, 3-variable equation. I also want to drop back to this example here from our notes and to erase what I have here so we can start the problem fresh. Historically, many of my students in Algebra 2 struggle with this type of word problem, this quadratic word problem, because it's a little different to set up than anything we've done in the past. Here we know that the amount of money that this souvenir shop owner is going to make, you can compute that by simply taking how many mugs he sells and multiplying it by the cost per mug. So this souvenir shop owner would make $1,200 because he's selling 200 mugs. They're $6 a piece. He would make $1,200. That's how every one of these problems is going to start. You're going to have a quantity times a value. What we're going to do, we're going to change this a little bit. We're going to put the 200 for our quantity, leave a little space, and then put the 6 for the value. And now as we continue reading in our story, we've already used this information. The shop owner estimates that for each 50-cent increase in the price, he will sell about 10 fewer mugs per month. So think about life in general. This past weekend, we had our fall play. If we sold the tickets for more than $10, we would make more money, right? If you sold them for $15 a piece instead of $10 a piece, you make more money. And for a while, that's going to be true until you start charging too much. Then suddenly, you don't have anybody coming to see your show. If you charged $2,000 or $3,000 per ticket, nobody would be able to reasonably afford the show, and then you wouldn't sell any tickets. So you would actually make less money. The whole point of these problems is to try to figure out how much can we raise the price and make more money before we charge too much and start to lose money. So it makes a parabola. That's why these are ideal quadratic problems. What we know is going to happen is that we are going to increase the price. So remember, price is over here. We're going to increase that by 50 cents. Every time we do that, we're going to sell 10 fewer mugs. This is our quantity over here. So it's dropping. Now, we're not going to just increase it once. We're going to increase it more than once, but we don't know how many times. So that's why we have to put a variable with it, because we do not know how many times we're going to add 50 cents to the price. But every time we do, we are going to sell 10 fewer mugs. So if we increase the price to $7, for example, that's 2 50-cent increases. We would sell 20 less mugs. From here, you can just use this equation. This is a quadratic equation in factored form. That's fine. You can leave it like that. But some people say, I don't like looking at it like that. I want it to look like ax squared plus bx plus c. That's fine. You just have to change it to make sure that it looks like it's in standard form by just foiling or boxing it. Gives us 1200, 100x, negative 60x, negative 5x squared. So negative 5x squared plus 40x plus 1200 is the same equation, but this is a quadratic equation in standard form. That's the difference. Both of these are fine. We can type both of these equations right into our Desmos graphing calculator. And I actually already have them typed in right here. You can see them typed in both in factored form and standard form. I'm going to close this so I can see more of the graph and zoom out. I can see my parabola. It doesn't look much like a parabola because it actually is a very, very skinny parabola. But as I scroll up to the very top of the parabola, I can start to see the very top of it. Just takes a while. There it is. And when I hover over that point, I get the point 4, 1280. Now remember, x, which in this case is 4, represents the number of price increases. So if I increase the price by 50 cents 4 times, that's a $2 increase, I can expect to make $1,280. So that's what we would type for our conclusion. If we raise the price by $2, which is 4 50-cent increases, we will make $1,280. By doing this, we are selling 160 mugs. Because remember, we've lost 40 mugs. We increased the price 4 times, so we are selling 40 less mugs for $8 each. That's how we would interpret that information. Now, one last thing to show you right here, if we go back home and it was hard to see our parabola, one thing you can do is adjust the settings of your window so that you can see it better. I know that my Y value is going to be up somewhere around 1200, just because 200 times 6. So if I make my Y value, I know it's never going to be less than 0. I'm not going to lose money. And I can make it go up. Let's see here, making my Y value 0, my X value 0, and I'll make my Y also go up probably to like $1,300. Now I can see that parabola shape a little bit better. I can still see what this looks like, but I can see that it looks more like a parabola instead of how very tall and skinny it was initially.